Hi, this is Raj Mehta, and this is our third video on our introductory series to evidence-based medicine. In today's video, we're going to start by going into our critical appraisal. Critical appraisal involves several things. It involves reviewing clinical trials, looking at study designs, understanding the difference between random error and bias, and then trying to either minimize bias when we apply EBM or try to identify bias when we're looking at studies. The whole point of critical appraisal is to look at the validity or truth of our evidence. We want to be confident that our evidence is valid, that we can believe its results before we go about applying it, and this is where critical appraisal is so important in medicine. In this video, we're going to be reviewing the different types of clinical trials and different types of study design, as well as different strengths and weaknesses. In our subsequent video, we'll go into randomized error and bias and how to attempt to minimize and identify bias. In medicine and in population studies, you'll generally find two different types of study designs: an experimental study and observational studies. Experimental studies are when you're doing an experiment on a population or individuals to see a result. Most experimental studies are randomized controlled trials, or RCTs. Observational studies, on the other hand, don't have an intervention. They're just watching a population over a period of time. The most common observational studies are cohort studies, case control studies, and cross-sectional studies. Let's look at each one of these individually. Randomized controlled trials are experimental or treatment studies. They attempt to evaluate an intervention. A randomized controlled trial begins with a group of eligible patients. These patients are then randomized into two groups. This process is very important. One group is a treatment group. The other group is our control. They usually receive a placebo. We then look and measure our outcomes and compare them to see if there's a difference. Next, let's move on to cohort studies. There are two types of cohort studies: a prospective cohort and a retrospective cohort. Let's begin by looking at a prospective cohort. In a prospective cohort, you, the study designer, start at the beginning of the study. So you're standing here, and you start with a defined population of people. Then you watch over time as one group is exposed to something and another group is not. This happens by natural selection. You're not intervening and doing this like a randomized control trial. Then after a period of time, you see the outcomes to see who gets disease and who doesn't. Let's use an example. Let's say I wanted to look at a group of children, and I wanted to see what happens if they were exposed to smoke. So by natural selection, we'll find that some kids at home were exposed to smoke because maybe their parents smoke, and some kids don't. No smoke. Then we watch over time, and I want to find out afterwards how many of these kids ended up with asthma. And then I compare. Did those kids who ended up with were exposed to smoking, were they more likely to get asthma than those kids who didn't or weren't exposed to smoking? The goal of a cohort study is to find who gets disease. Okay, it's trying to figure out who's getting asthma. And we control, or we observe, I should say, our exposure. We're observing the effects of smoke. Now, a retrospective cohort is very similar to a regular or prospective cohort. But you, the study designer, you're over here. You're starting at the end of this. And this often happens when you're looking back at charts. Let's say that I want to go back and I want to find the same question. I want to find out if kids are exposed to smoking, are they going to get asthma? And so I look into a computer database and I go back in time 5 years. 5 years. So I've gone back in my computer databanks and I select 1,000 charts at random in my computer databank with a bunch of kids. So I define my population. I find like 5,000 charts of children. And then I conduct a chart review and I see how many of those kids were exposed to smoking, how many were not exposed to smoking. Then I watch over time. Then I see who got asthma. It's a cohort study because, again, I'm interested in knowing who developed asthma. I'm observing the exposure of smoke, but I want to know in the end who got asthma. So I'm still looking at the disease outcome. And what changes the prospective and retrospective? In the prospective, I start here. I define something, and then I wait maybe 5 years and I get my results. In a retrospective, I just go back in time and do this process. Next, let's look at case control studies. Case control studies are a little bit different from your cohorts. In case control studies, you, the observer, decide that you want to go and do chart reviews to go back in time to find out if someone with the disease was exposed to something or someone without a disease was exposed to something. The goal of a case control study is to find out what exposures might have caused the disease. In a case control study, you begin by knowing who has the disease and who doesn't. So let's use an example again. Let's say I want to find out if allergies increase the risk of you getting asthma. And I decide to find 100 kids with asthma, and then I find 100 children that don't have asthma. Then I go back to try and figure out if the kids that had asthma, were they exposed to allergens? And if the kids without asthma, if they were exposed to allergens. Then I try and compare how many of those kids were and weren't exposed to allergens to find out if allergies may increase your likelihood of getting asthma. The key difference between case control and cohort is in cohorts you start out already knowing the disease. You start out knowing whether they have asthma or they don't, and you need to go back in time to find out whether or not they were exposed or not exposed. Let's compare that to our retrospective cohort. In our retrospective cohort, we already know the allergen information. We know they were exposed to smoking or not smoking. We're trying to find out whether or not they developed asthma. Finally, let's discuss cross-sectional studies. Cross-sectional studies attempt to look at a population and see if they have a characteristic, and in one snapshot moment in time, determine if they have those characteristics or not. Okay, so it's a snapshot in time. Let's say if I had a group of children and I want to find out how many of those children are exposed to smoke at home at this time. I could do a survey. That would be a cross-sectional survey, and I'd find out in that moment whether or not there were smokers in the home or not. It wouldn't tell me whether they're more likely to be smokers in the future or less likely to have had them in the past. It just, again, tells me in that moment in time. Now I want to briefly review two different concepts: incidence and prevalence. Incidence is the risk of developing something over time. Incidence tells us how likely a disease is going to occur over a specific period of time. Prevalence, on the other hand, tells us the proportion of people with the disease at a specific time. At a specific time. Now let's look at our different studies to determine if they tell us incidence or prevalence. Randomized control trials and cohort studies tell us about incidence. So if I want to know the incidence of asthma in children, I can do a cohort studies, watch a defined population of children over time, and see how many of them develop asthma. So I have a disease, which is asthma. I'm watching them over a period of time, and that will give me the incidence of asthma in that group. If I did a randomized control trial, similarly, I could see the incidence of asthma or disease developing or not developing if I gave them a treatment. Let's say I give a bunch of children with asthma in one group steroids, in another group I didn't. Well, then I could look at the incidence of asthma in those two groups. Cross-sectional studies tell us about prevalence. They give you the snapshot in time of that characteristic. So if I want to know, let's say, how many children have asthma, and I do a survey of 1,000 kids to find out how many have asthma, that will tell me the prevalence of asthma, okay, in that one moment of time, the prevalence. Case control studies can't tell me either, because case control studies begin with knowing whether you have the disease or not. In case control studies, I find kids who have asthma and I find kids that don't have asthma, and then I start to do my study. So it can't tell me anything about the prevalence of asthma at all. I don't begin with a defined population. Next, let's move on to discussing systematic reviews. Systematic reviews combine multiple high-quality studies on a specific topic They use some focus methods to identify, appraise, and select them, and then they synthesize the information. So they synthesize lots and lots of studies together for you. And systematic reviews, when done well, are usually considered the strongest form of evidence in medicine. And the most common systematic review you'll find are meta-analysis. Now, when we're doing critical appraisals on all our different types of studies, they each have their own strengths and weaknesses. Systematic reviews are usually considered the strongest form of evidence because they synthesize lots and lots of information together. The problem is that they're difficult to do. They get outdated quickly. If you do a systematic review and 2 years later a new study is published and is not included, that systematic review is outdated. And also, not all topics can do systematic reviews because maybe there's not enough evidence out there for them to synthesize something. Randomized control trial, especially for interventions and treatments, are a really strong form of evidence. They're our gold standard. But the downsides or weakness of randomized control trials are that they're costly to do, they take a lot of time, they may or may not be generalizable, and you can't determine harms from randomized control trials. It's not ethical to do a randomized control trial to see if something's harmful. So you can't look at harms. Cohort studies. The strength is that they're the strongest type of observational studies. They're really, really good. Their weakness? Well, they're not as good as randomized control trial. Why? Because you're more likely to have bias. More bias in cohort studies and randomized control trials. Case control studies? Again, their strengths, they're cheap to do, and they're really good for rare diseases. When a disease is very rare, you can just do a case control study to look at and study that disease. Again, the weakness is there's more bias in this than there is in a cohort study. Finally, cross-sectional studies, they're very easy to do. They'll give you a quick snapshot of a disease or characteristic. Their weakness is, again, they have lots and lots of bias. So in our next video, we'll be covering more on critical appraisal and discussing bias in more depth. Thank you for listening.